Hi guys, welcome to another video. Today we'll be solving the Leetcode daily challenge from 7th July. Um, One more thing, so from my previous video, I felt that the video looked very scripted and edited, and I did not want my videos to be like that. So I'm going to change the way I'm making these videos. This one is going to be very raw. Um, मैंने अभी तक क्वेश्चन नहीं देखा है so I'll open the problem. I'll see, I'll try to make an approach and so basically try to give you guys an insight on how I approach these questions, how I build my logic, and how I tackle these. I don't want to straight up give you the solution because you can just open the discuss section for that. Um, we are here to build the logic, and we're here to develop the thinking whenever we get a new question. So let's try to do it like that. All right, let's get into it. So the question is water bottles. 1518 easy level. The likes dislikes look fine. Let me see. Yeah, so there are a number of bottles that are full. We can exchange this numExchange empty water bottles from the market with one full water bottle. Okay, so you give this many and then you get a full water bottle. Operation of drinking a full water bottle turns it into an empty bottle. Okay, two integers. Return the maximum number you can drink. Okay, so let's see the example. This one is saying I have this many. I'll drink all of them. Right. So I'll have all the this exchange rate is let's say three. So for every three bottles, I'll get one filled bottle. So the total number of bottles that divided by three is the number of bottles I can get filled. Got this. I drank all the three, and then I'll try to exchange it again. Okay, good. Seems pretty straightforward. Okay, if you have 15, exchanges four. So for every four bottles, I can get one back. So 15 by four is 3 point something. So I'm guessing we'll get three bottles back. Oh, we have some in storage. We can keep the empty bottles with us. We'll try to. Oh, okay. So there's no need to discard all the bottles. Okay. Um, Only the ones that we can get filled. So let's say we had 15. Hmm, Try to build some logic here. We had 15 and exchange was 4. Firstly, we'll drink all the 15, and from the 15, I can exchange a few. So, I think we'll should open the dropboard. Yeah. So we have. Oh, okay. Yeah. So we have 15 bottles, and exchange is 4. So let me keep a track of two numbers. This is how many I'm drinking, and this is uh, available to exchange. To exchange. So in the beginning, I'll drink all the 15. Available to exchange is 15. Out of these, how many can I get converted to a filled bottle? So that is 15 by 4. This gives me 3. So 3 can be filled. And how many bottles do I need to give up for that? So that is 12. So 15 minus 12 would be 3. I'll be left with 3 empty bottles, and I'll drink the 3. So these 3 plus we'll get another 3. So we'll have 6 bottles here. Now in the next turn, it will be 6 by 4. That is one bottle I'll get to drink. How many bottles will I need to give out for that? That is, I'll be losing 4 bottles, so I'll be left with 2 bottles here, and 4 I will give to get this one free. So I'll drink this one. This will be plus 1 here. This will be 3. So there's no point of going forward because we are left with 3 bottles, and uh, can't give the 3 to get any filled bottles. So this is 15 plus 3 plus 1, 19. Let me check if that is the case. Correct. Got it. Uh, Basically, we'll need to keep uh, track of total. bottles we are drinking, and we will also need to keep a track of empty bottles available. um, Exchange maximum possible empty bottles, oops, with filled ones, and we'll keep doing this till the number of, okay, uh, keep doing this till number of empty bottles is greater than num change. Okay. Mm, okay, so I think firstly we'll need a number of empty bottles. So let's say I have number of filled bottles. In the first case, I can directly drink all of them. Correct. So int bottles you can drink, bottles drank equals to num bottle. So this is the starting condition, and int, so empty bottles equals to. We'll tell you why we have to do this. So in the first case, whatever bottles are available with us, all of them are full. So we'll directly drink them. So number of bottles you drank in the first case is equal to number of bottles available, and all of those bottles then become empty. So all can be recycled again. So this is how we can start. And oh, oops, like it is mentioned here, we need to do something, but we can do that till the number of empty bottles are greater than the number of bottles we can exchange for one bottle. So while this is greater than, it is greater than equal to also num exchange. Okay, so what we'll need to do is every time I'll need two new bottles, get some new bottles. Okay, new bottles, I'll get some new bottles, and this will come from how many bottles I can get for the number of empty bottles that I have. So that will be empty bottles divided by the exchange rate for these bottles. This will be the new bottles I can get. Mm, and int bottles spent. How many bottles do I need to give uh, to this person? So this will be new bottles star the exchange rate. Now, uh, this is equivalent to actually the bottles that I need to give is mm, so let's say I had 15 bottles. From 15, 15 divided by 4 is 3. So 3 bottles, in this case, 3 bottles I can get. But how many bottles did I actually give to get these 3 back? Is 3, which is the number of bottles I can get back star multiplied by the exchange rate. So that was 12 bottles I gave out. So that means bottle spent was 12, and new bottles I got was 3. Okay, so what we need to do is the new bottles that I got. These are the new bottles that I can drink. Correct, and the bottles spent is I don't have these available anymore. So empty bottles minus equals to bottles spent, and bottles drank plus equals to the new bottles that I got, right? And so these new bottles again they become empty bottles. So empty bottles plus equals to new bottles. Okay, this should be it. Let's just once again verify everything. So int bottles rank is the number of bottles, that is where we start. So this was 15. Both are 15. So this is 15. Empty bottles are also 15. While this is happening, new bottles would be 15 by 4, that is 3, and bottles spent would be 3 into 4, that is 12. So empty bottles, I'll reduce 12. Will be left with 3. Bottles drank would be new bottles, 15 plus 3, 18, and empty bottles would be 3 plus 3. 3 plus 3 is 6. So I have 6 bottles. 6 is greater than 4. 6 divided by 4 gives me 1. Bottle spent is 4. Okay, so empty bottles, I'll reduce from 6 to 2. Bottles drank would be, new bottle is 1. So 18 plus 1, 19. And empty bottles is what it was 2. 2 plus 1, 3. 3 is not greater. So I can return from here. Okay, cool. I think that's it. Let's run it for the test cases, and then we'll try to submit this. I think that's pretty much it. There shouldn't be anything left. Let's check the time complexity also once. Number of bottles is 100 and number of exchanges is also 100. So this is uh, yeah, should run. Worst case it is linear. Yep. All right. Oh, thanks. Yeah, so that was it. Go back here. There's nothing much here. Yeah, that's all. Let me know if you have any doubt about this question in the comments. Mm, yeah, also, if anyone wants these videos in Hindi, we can do that also. So if you need these videos in Hindi, just put one comment. Even if one person asks for it, I'll be happy to make another video explaining the logic in Hindi. No worries. This is in Java. Again, if someone wants this in C++ or Python or Go, just drop one comment and I'll make another video solving this in any other language that you want. All right, that's all from my side. Um, yeah, again, format from now on will be the same. We'll try to think of the logic first, build the steps that we want to how we want to solve, and then solve the questions. And I would suggest you follow this pattern initially, at least till you develop your own flavor or your own method of solving these questions. Yeah, that's all. All right, thanks a lot. See you in the next one.